Speakers, my distinguished colleagues, Mr. Vincent Habers from the Dutch Ministry, Mr. Tom van der Ven, front row, for mobility sensing. And if I'm allowed, I would like to give you some perspectives from the Dutch Ministry as to the why and the how and where we come from. And our main focus at this moment is the city, urbanization, which is a global trend. In a couple of years, 95% of the global population will be living on 5% of the land surface. You can imagine that, 95% of 5%. In the Netherlands, we want to add another 1 million homes in 10 years. So with 1.6 average household, cities might become a bit crowded. That's nothing new because, we were used to that pre-COVID. But what we also need to do is get a grip on our nitrogen crisis. We want to get a grip on the energy crisis. We need to become way more sustainable than we were used to. So it is a culmination of different challenges that we need to tackle all at the same time. And then again, this is daily life in all our cities. Large and small, goods coming in, garbage going out, people visiting, people working, commuting, with all modes of transport. And the trick is, how can we make that as smart and sustainable and as inclusive as possible, while at the same time as public authorities, public organizations be as efficient and as effective as possible. Because in cities like this, if we want to add 1 million new homes, we do not want to build into the green unbuilt environment. We have agriculture there with its own challenges. We have nature there. We want to have our own recreation possibilities. So we need to densify our cities, concentrate new homes within the existing urban built environment. And that means that every square meter is at a premium and is also, it needs to accommodate several functions at the same time. It needs to adapt water. We might want to use it as a parking space. We want to have a tree there to reduce heat stress. So that is a big challenge. But we need to tackle this now. It's not going to go away. These challenges will increase if we do not act. And these are our shareholders, current and future. Now, Mom didn't want to mess up her hair, so she's not wearing a helmet, but the kids are. And it is the future that we're building. This is for these people. So, with an additional 1 million homes, a massive reduction in emissions, 55% at least, but our national government has set a target, an ambition for at least 65% reduction. We already had an energy crisis, now there's a war on in Europe, so that makes it a bit more pregnant and more crucial to come up with new solutions. Now what we're going to get into this afternoon is how we already have a program and already have technology within the city framework operating on a daily basis, where it came from, how it evolved, what it's doing, where one relatively simple but also very complex infrastructure accommodates a multiple range of use cases that we want to build on, that we want to expand on. And that is where Tom also comes in with his sensors and the data that sensors will produce. So, on that note, I give the microphone and the clicker to Vincent Habers. Yeah, come on, you're going to go on the catwalk. Good luck.
Thank you. Let's try to figure out, yeah, okay. Yeah, here it is. Um, yep, pick up where Casper left. That's never easy, but trying to. What you saw as the title of this set of presentations was that we consider Talking Traffic as to be the cornerstone of smart and sustainable cities. Sounds nice, of course, but in order to really understand why we think that this is the case, it may be useful to understand what actually is the essence of Talking Traffic. I tried to break it down to actually 4 items that really cover what Talking Traffic is all about. It's about bringing data about the environment to the vehicle and the other way around, from the vehicle to the environment, by using cellular technology. And even though we don't actually have any preference whatsoever for what technology whatsoever, the results count, but having the long-range communication enables us to increase the horizon on which intelligent infrastructure components can form an opinion or can form a strategy on how to deal with arriving traffic or with situations where traffic is involved. Well, you may have heard about Talking Traffic, and most people do associate it almost automatically, instantaneously with traffic lights. And that's correct. I mean, we do have something to do with traffic lights, quite a lot actually. The provisioning of priority to several road users is an important component. We are now able to provide priority to, for instance, trucks based on whether they're empty or whether they are loaded, whether there is dangerous goods loaded in these vehicles, or only a set of baby diapers, whatever. So we can distinguish depending on the load of the truck. When it comes down to public transport, we can distinguish on the bus being full of travelers, or the bus being ahead of time schedule or behind time schedule. This may influence the level of priority we can provide them with each of the traffic lights which have been made intelligent traffic lights. That the emergency services are being given priority may not come as a surprise, but do realize that due to the fact that we can provide them priority, they now can cross the crossing using green light. And all the other participants in the traffic have red light. That makes a huge difference, because most of the time in previous situations they had to use their blue light and signal in order to indicate that they were crossing through red light. Every week, on the average, an accident happened with these kinds of situations, these kind of vehicles. And that's of course not what you can wish for. We have the technology, we have the organization, we have the value chain in order to improve. So this is one of the first things we did. And we're still going strong in that one. Not all of them have been taken care of, but we're working on that. Another use case that may be familiar to you, some of you, is the fact that we can provide the individual vehicles with the current light image. They can get it on their smartphone, on their dashboard if they've got Apple CarPlay or Android Car. But then it makes it possible to see already what the color of the light is, even though you cannot even see the traffic light itself. Quite handy if you're in a row behind a large truck. Quite handy if you need to anticipate on the situation ahead of you. Due to the fact that we can exchange data between vehicles and the traffic lights, we know where one is going and which traffic light is intended for his route. Another one, not very obviously visible, but very important in getting the traffic flow easily through cities. That's the optimization of networks using traffic lights in order to get this, I don't know actually if it's the correct English wording, but the green wave. That's literally translated from Dutch, so I can understand if somebody has a problem understanding that. But having a set of traffic lights being synchronized to each other, that can help in order to avoid heavy trucks, buses needing to stop. Every stop that can be avoided saves fuel, saves noise, saves potential damage to the road, saves braking energy. So it's worthwhile trying to do your best in order to have these sort of vehicles fluidly taken through town. Talking traffic, however, is more than only this. It's more than only traffic lights. It's also about commandments and prohibitions. Sorry. Most obvious ones of those are the traffic signs and the maximum speeds in a lot of countries. But in the Netherlands, it's very hard to realize what actually is the maximum speed I'm allowed to drive, given my vehicle, given the moment of the day, and given the road I'm driving at. There's a whole lot of, well, time-dependent maxima. There's a whole lot of situational dependencies. We communicate, at least Talking Traffic communicates through the information services to each and every motorist what exactly is the maximum speed he's allowed or she's allowed to drive, given the vehicle, given the time of the day, and given the location on the road network. Warnings and advices, a very important one as well, taking in consideration that there's only so much you can see through your windscreen. Just as little further down the road or around the corner, there may be something happening that's very worthwhile for you to realize or to anticipate on. Talking Traffic helps you to realize this and to be aware of this specific fact and to anticipate on that. Whether there is a bridge open or a accident being or happening, or a hazardous goods on the road, an animal on the road. This safety-related traffic information in general terms, they can be provided to you tailor-made depending on your route, depending on your vehicle, so that you will be not bothered by information that's not of any value to you, but you will be bothered with this information that is actually a warning for you where you need to anticipate on. Parking information may seem a very obvious one, but if you realize that about 20% of the vehicles driving through town is traffic looking for a decent, suited parking spot, then you realize how important this sort of information is in order to increase livability in cities, increase or decrease the number of kilometers driven in urban areas. So parking information is quite an important one. Moreover, not only the static parking information, where is a parking garage, what's the opening hours, what's the tariff, but also the dynamic one, is there actually a place for my car, given the height, given the width, or given the fuel it runs on. So this is more than only just traffic lights. Other than that, we have not only more use cases than most people realize, we also have more intelligent infrastructure. Currently, today, we already have in operation a set of bollards, what's the word for that? Bollards, I think is the correct English word, in several cities. Tire pressurement systems, where a truck can, without speeding down, drive over this tire pressurement system and will be informed in car what exactly is the condition of the tire pressure. Is it too high, too low, or is it correct? Per axle, per wheel. And the detection of bicyclists, an important one for us, not only because we have so many bicyclists, but also because the fact that we do realize that on the one hand, we forbid bicyclists to use an app while bicycling, and correctly so, I'd say. On the other hand, when they have an app, we can communicate with traffic lights using this long-range communication technology and let the traffic light know that this bicyclist is approaching, and let the bicyclist know that the light will be turning green for him. So there's a bit of a, chicken and egg situation where when we have the detection radar or camera-based of bicyclists, we can at least detect the bicycle that is approaching and let the bicyclist know by vibration of his smartphone or with an audible signal that the light will be turning green. So there's an important factor for that. When you put it all together, this looks like this. A bit more complicated than actually was needed, but on the left, upper left corner, you see all the intelligent infrastructure. There's a whole range of that, but traffic lights, bollards and barriers, and tire pressurement are the ones I just named. On the left, you see the sensors, quite a wide range of sensors, but they can also be connected to the central element in the value chain, UDAP, Urban Data Access Platform. The previous speaker, Menno Malta, was diving into UDAP. He was representing the manufacturer of it, the service provider for UDAP. But it is a facility which is key to the whole value chain, is owned by the Dutch government, and therefore it enables the Dutch government to control whatever happens in the value chain to avoid that privacy is infringed or to avoid that data security is at stake. Data is another important factor because of the fact that there is the data on traffic situations, there's data on the actual environmental zones. There's a whole lot of data in order to be processed and to be communicated to all stakeholders. On the right-hand side, cloud service providers, we've got several of them, each of them serving a set of the road users, a set of information services, some of them only bicyclists, some of them only public transport, but all in all they serve the whole community of road users. When you compress this a little, you get this more like a chain, where it is good to realize that the left-hand side of the value chain is predominantly owned by governments, influenced by governments, and the right-hand side is predominantly influenced by private companies. And there's an important reason for that, because as a government we want to avoid at all times of getting data available that is to be considered as privacy infringing or could potentially has to be handled under the GDPR. So we want to avoid, and the whole system is designed in a way that we will not be able to detect or to know exactly what is the set of data, the personal data of each motorist. Because we do realize that motorists will not like the one more than the other, will not like governments knowing everything about them. That's not necessary, and therefore we will not. In addition to this visualization of the value chain, it's good to realize that the use of this value chain for all sorts of use cases is made mainly possible because of the fact that there is some specific requirements in place. Some of them being the ETSI standards used or the Dutch profiles, or there is a set of requirements you need to answer when you want to connect to this central piece in the value chain, UDAP. There's a license agreement in place where the organizational component, the less technical components are involved. UDAP is continuously measuring KPIs from all parts and all actors and all objects which are connected. So when your KPIs are not above a specific threshold, then you may end up seeing your object, your traffic light, disconnected from UDAP, has happened. So this means that all parties that are active in the data chain can rely on the fact that even if it is a traffic light owned by the government, if it's not matching the requirements as set in order to connect, it will be disconnected. It hurts us, believe me, but we do so. That's the only way to guarantee the quality within the whole of the value chain. On top of that, there's the frequent, periodically, data protection impact analysis, DPA, in order to check whether all the actors in the value chain are still respecting the GDPR. Periodic audits on data security. A testbed shared with Flanders. You may have heard about Mobilidata. That's more or less talk and traffic in Flanders. We share an international testbed where companies can very soon start testing their new inventions and can also prove that they're still matching the requirements set, and therefore their certification, which annually expires, can be extended with another year. And then we've got the governing bodies, which are as a neutral set of bodies governing the whole of the value chain, a change advisory board containing the operational representatives of all parties in the value chain, and a strategic committee which is formed by the minister and contains some representatives from ministry and from some participating companies. So there's a whole range of measures in place, together with the way the technology within the value chain is organized and the organizations that are participating, that makes it possible for us to expand on the current use cases in order to provide intelligent access. Intelligent access, UVAR, another term that may be used for that, enables communities to filter traffic filter based on specific criteria. If you are an inhabitant of or a resident of a city, you may be allowed to drive with your car all the way to your apartment or the garage below your apartment. But if you're only a visitor, you may see yourself being stopped by a specific point in town where you need to park your car, or even stronger, you're advised to park your car in the hub on the ring road around town and are being taken care of with electrical transport or public transport into town. So there's the need in order to have the ability as a city to increase the number of buildings, be it offices, be it shops, be it homes. If you need to improve on that, you need to make space available, space currently occupied by traffic, in order to, use that space for other purposes. And therefore, filtering of traffic may be a very, very important element, condition to do so. One of them is the cargo bikes. Having a zero-emission zone in place, you need to have an alternative for those that need to go into town with some stuff to be carried around. Coolblue is an example of the electronics merchandiser that uses quite a lot of these cargo bikes. But as you, as a government, can provide priority to heavy goods vehicles, well, why wouldn't you for cargo bikes? Why wouldn't you, as cargo bikes tend to be quite big on a bicyclist piece of the road, why wouldn't you allow them to drive on the road itself, providing them with facilities, privileges if you wish to do so? The current value chain makes this possible. You could condition this even stronger on air quality or on weather conditions. When the weather is bad, your bicyclists or your cargo bikes can get a higher level of priority and therefore have a larger chance of getting the green light on a crossing. Quite easily possible with the current set of messages we've got in the value chain and with the current organizations. A bit stronger, the zero-emission zones. They will happen within a couple of years, 2025. You will definitely see the first zero-emission zones. Quite a lot of communities have already taken care of the legal preparations for that. But they don't have yet taken care of the organizational aspect. How are you going to maintain this? How are you going to enforce that? Well, the current value chain can. If there is a declaration from a vehicle stating that it is not using an internal combustion engine, but only the electric propulsion, its service provider can, just as the accountant does for a company when it comes down to the, annual the tax declaration, this service provider can declare to the whitelist in cameras that the specific vehicle that is passing not using his internal combustion engine, but is using his electrical propulsion. This enables, with respect to privacy, this community to only enforce these vehicles that do not match the criteria. Because when leaving this geofenced environmental zone, you can automatically delete this specific characteristic, this specific vehicle from the whitelist. You can even take a further step and make it dynamic. It's harder and it's not next week, I'm pretty sure, but you can also decide on, depending on the air quality measured by sensors, the geofence in which the environmental zone conditions are applicable may differ. You can communicate this in car and you can use the same methodology as for the zero emission zone to distinguish who is compliant and who is not. And you can even combine this with active rerouting. When this dynamic low emission zone is active, you can also advise these cars, these participants in traffic that do not match the criteria to reroute, to take another route in order to avoid being enforced. Because you know the characteristics of the vehicle, because the service provider can, as a service, help them in order to not be enforced and still be able to reach their destination set. The air quality sensors can let the government know that it's time to, well, take this into consideration. And you can also see on the roads itself, by the floating car data, for instance, coming out of these cars, that it's about time to do something on your dynamic low emission zones. Parking restrictions. As an inhabitant, a resident, it's pretty lousy if you find your parking place occupied by another one, not entitled to do so. It's quite easy when having the talk and traffic value chain in place to make sure that only the residents can park in a specific reserved set of parking places, or shared mobility providers, that only they are able to park without being enforced, or that only they are being able to pass a barrier without any additional means than they already have in order to navigate, in order to get the traffic light information. It's the very same technology, nothing else, no specific extra card, which enables the service provider to provide these services and make sure that only those entitled to this parking place can actually start using it. And the enforcement officer, you see on the left-hand side in the pictures, will have the whitelist in his device available to immediately see whether a vehicle is entitled to park there or not. Or, when taking parking in a larger scale, restricted access to parts of town. For instance, the marketplace or the inner city part. You can use these bollards in order to decide who's allowed to pass and who isn't. Once again, without any additional pass or transponder or what have you, just with the very same technology used to communicate with the traffic lights or to communicate with the barriers, you can decide on who's about to pass and who's not. And you can also communicate that, well, you may pass, but there is a garbage collecting going on, and it may be very hard to continue your way into town because you have to stick behind that. All sorts of services the service provider can provide, knowing your destination, knowing the characteristics of your vehicle, and having the data available to provide it to you. Unloading places, an awful situation when you listen to drivers of large trucks. Then you've got only this limited time window to unload your truck, and then you're finally at the destination, and there is another truck on this position where you were hoping to park your truck in order to unload. I've heard stories about truck drivers in Amsterdam that because of the one-way traffic, they needed to drive for half an hour in order to get again to the specific place before they can have a new attempt. That's awful. This is not helping a smart city in achieving its goals. So it is very helpful to make a reservation to avoid another one parking there based on the characteristics of that vehicle. You know it as a service provider, you know where it's going to, you can make sure that no other one can park there because you have the characteristics in the whitelist. And once again, also the enforcement officer can use these characteristics in order to eventually provide penalties. It requires data, that's for sure. It requires a lot of data in order to use the value chain, one and the same value chain, for all these additional use cases in order to make a city really smart. That does require data available in near real time to at least service providers and governments that need to switch specific dynamic regulations. Sensor data is a very important one in that. And Tom, representing mobility sensing, is going deeper into that one. Tom, can I hand over to you?
Thank you, Vincent. Can we switch to presentation? Yeah, thank you very much. My name is Tom van der Ven, the CEO and founder of Mobility Sensing. So we take infrastructure online. So I want to talk a bit more today about what talking traffic, when combined with the latest IoT technology, can do. So first, I think we need to talk about smart city. So I think smart cities need smart public spaces. But first, we need to ask ourselves, why do we do this? A smart city is not the purpose in itself, it's a means. So why do we do it, for whom, and what do we need before we get to the how? So why do we need smart public space? I think we all agree that city roads and streets, they are essentials for citizens and businesses. But of course we also know that traffic has its downsides, both in terms of pollution, noise, air, etc. And if you look at the Netherlands, we see that many city streets are heavily used. And of course, they're expensive to construct and to maintain. But also, we see that they're largely dumb. So in the Netherlands, for instance, we spend every year 2 billion euros on constructing and maintaining roads. But if we look at how many streets actually have sensor data, that's less than 2%. So we spend a lot of money on building roads that are dumb. And we think we should change that. So for whom should we want to make this public space smarter? Of course, there's many stakeholders. We have all the road users, not just the car drivers, but the cyclists, the pedestrians. And we need to make sure that they get the information to get from A to B safely and as efficient as possible. But of course, that can only happen if the road manager can do his job. So the traffic planner and manager, they need to have the information to carry out that job. And the road operator also needs information to optimize road and asset maintenance. And of course, we should never forget about the resident, people living near city streets and roads. They are entitled to know what's happening in their road and if it's properly maintained or not. So, what do we need? We think we can make all that happen if we have more and better data. So, if we get live insight in traffic flows, that we better understand traffic patterns in cities, that we can warn road users for unsafe driving conditions, and that we can have data to optimize the maintenance of streets and city assets. And maybe more importantly, as we see often, is that data is collected and then is used at one point. But if we combine data, then the true value comes to life. So we should share the data that we collect, and in particular, combine it with data from other sources to make better information. And then, of course, you need to tailor it. I mean, there's no point in collecting tons of data and making valuable information from it if you're not capable of sharing it and bringing it to the right stakeholders, all these different stakeholders, bring the right information at the right time and the right place. So how can we do that? Well, the great thing is that there's all kinds of technological developments going on that will facilitate this. So we have IoT data communication networks that allow you to communicate low power, small data packets. And you can do that in near real time. So it's wireless data communication, which requires almost no power. We also see that artificial intelligence is becoming omnipresent. You can implement it in the cloud, but you can also implement it in the edge, in network edges, but also in devices. And development kits allow you to do that ever more easily. And also important, power harvesting and power storage is also improving significantly. So we've seen tremendous steps in solar power. It's becoming more efficient. It's becoming thinner, also foldable. But more important, it's becoming ever cheaper. And we see new power harvesting methods emerging as well. So harvesting power from radio waves or from heat potentials or flowing water or waves on water, etc. All these methods provide limited amounts of power, but it's enough to power IoT-driven devices. So where does that bring us? Well, it allows us to build autonomous devices, sensor pods, that are completely independent. So they make sure they collect their own power, they have their power storage, they can measure things and then can relay that to a backend. And one of the great things is, of course, you don't need any cables anymore. You don't need cables for power, you don't need cables for data communication. So you can make devices much cheaper to install. It's just one box, it's closed. So it's easier to install, it's more robust, it's more secure. And if you design it properly, you can easily install them and swap them. So the total cost of ownership of such a device are much lower than for conventional data collection systems. So how does that factor in with talking traffic? Of course, as Vincent explained, talking traffic is a great platform for sharing information between road users and the road infrastructure. So if we can make the road infrastructure and the city streets smarter, there's a tremendous potential for, to get all kinds of benefits. There's a great opportunity there. The great thing, of course, of talking traffic is that all the data that's exchanged is machine readable. So it can be used by humans, but it can also be used by automated driving vehicles. With the UDAP platform, you can make sure that this information ends up at the right time, at the right place, for the right road user. So it's a great way to share smart city data with all road users. So I want to give you some examples of what has been achieved already or what can be done quite fast using IoT technology and talking traffic. So this is one of my favorite examples. In the Netherlands, we have 1,500 bridges that can open. Waiting for an open bridge is one of the top 3 nuisances of car drivers in the Netherlands. And a few years back, we came up with the idea that it should be very easy to build very compact IoT devices that can simply detect if a barrier is open or closed, or whether the light of the bridge is on or off. So if you can do that, you have a solution that you can retrofit to any bridge that will tell you if the bridge is open or not. Through the IoT network, you can share that data with all the road users so that they know when the bridge is open and not. So the great thing is that when we started, there were just 50 bridges online of the 1,500, and that increased 7-fold because of this really economic solution to take bridges online. Another interesting example we've been working on, and what's available right now, is that we have street sensors that can warn locally for skid hazards. So if you enter a road where one of these sensors is mounted in the road, it will warn you for potential black ice or snow or whatever, so that you can be extra careful. And the last example I want to give is asset management. We developed a prototype of a device that can detect tilts and sudden shocks in assets. So if you have a traffic sign or a light pole or a bench or a bus shelter or equipment in a playground, all kinds of things, you need to know whether they are still standing upright, and if something hit it, a car or whatever, or maybe vandalism, that can be done with a very simple, tiny solution, a tiny device that's low cost and that can be glued to any asset. So that's the last example I want to give. So in short, IoT for smart cities, I think we have all the ingredients available to make it work, and we can collect tons of data from ever lower cost. So if you combine that with talking traffic, there's a great opportunity to get more information from the road infrastructure to the road user. Thank you very much. Are there any questions? Yeah.
Hello. So right away, you might know from my accent, I'm from the U.S., so I'm learning a lot about the business over here. And I'm with a private company now. We provide a lot of the smart infrastructure solutions, especially on the arterial roads. But recently, I was the director for a traffic management center in Las Vegas, so I have that experience as well. So I was looking at Vincent's slide. He had the public sector on the one side and the private sector the other, and UDAP in the middle. But where do the product providers live in that? How does a product provider like my company Cubic inform the government and basically the government, because ultimately you make the decisions on the products you purchase, but we have a big role in that as well. A lot of times a consultant will do a study for a government agency, hand off the results of the study and say, go buy this product. They come to us, but our product still has a lot of nuances that need to be fitting into this. This is great information, but there's still a lot of complexity that exists. How does that get provided for?
You're not going to answer the question, I suppose. If I understand your question correctly, what important is that in the whole value chain, there's a place for private companies, even though it's on the blue side, the public side, because the government does not manufacture traffic lights, for instance. These are all private companies, but it's owned by governments. On the right-hand side, the ownership is not so much at the government side, it's the private side. If your company wants to participate as a service provider or as a provider of information services or as a sensor provider or whatever, there is a set of regulations, a set of requirements your product or your service has to come up to, has to do with things like latency. We do require ultra-low latency, has to do with data security, privacy, has to do with reliability, availability, general conditions actually. But we want to make sure that the product or the service that is connected to the value chain does come up to these requirements. If so, then you're more than welcome to join, because it's not a closed environment, it's open for anybody. It's free for anybody. The more the better, I'd say, because in the end, do realize that the government only started this whole talking traffic scheme just for the effect it has on the road. Less pollution, less dangerous situations, and more livability in cities. So if that's answering your question, that... okay.
So is the talking traffic something across the whole EU, or is it specific to Netherlands? If I needed your services to run logistics between here and Lisbon, will it work on that type of effort?
Very good one. There we're a bit handicapped that the Netherlands is quite small, and our no, I'm not going to make that joke. That's not a joke. It's bidimensional actually. Yes, we do work according to international ETSI standards. So we do use ETSI CAM, ETSI SRM. It's all internet ETSE, European Telecommunication Standard International. Zoiets. It's a French abbreviation for a European standard. So the standards we use for exchange of information between actors in the value chain is according to international common practice. But, well, it's currently only implemented in the Netherlands, Flanders. The Nordic way is quite similar, not exactly the same, but quite similar. There's interoperability between that. UK is, oh, Menno's already gone. The provider of UDAP Monoch had a proof of concept recently in the UK. Hopefully they will take steps in that as well. But it's rather limited. Unless you're looking at it from an information service point of view, there are information services participating in talking traffic that are available in the whole of Europe, that are active in the specific countries according to what's available there. Most of the time it comes down to what data is available. We have data available from traffic lights, but we're virtually the only ones. We've got data available from dynamic parking information, but we're virtually the only ones. So there's a long answer to a short question. Yeah, we need to start somewhere, and we decided to take the Netherlands because we live here. Yeah. Okay. You were asking whether there were questions. Are there more people curious to find out every single detail about talking traffic, sensors? There you are. Is it about sensors or? No. Okay, I'll be glad to work. Don't worry.
So the solution you were presenting, you're quite, you need the service providers on the right side to get the information to the end users. So what's the business model for the service providers? how do they make their money? Do you also pay them from the public side, or is it just that the end users have to pay for the services?
Very good question. Thanks for that. We started in 2016 with a public tender, European tender, asking several companies within the value chain to participate and to join us in order to make this happen. And they were paid a specific sum amount, an amount of money for that. It was conditional on whether they matched requirements, whether they succeeded in the development, because what we asked for was not yet existent. So that was only fair in order to pay companies for the services delivered and the services developed. The contracts we closed with these companies all ended on the 31st of December 2020. From that moment on, no single company is being paid anymore for the services delivered within the value chain. And as we were hoping for, there is a specific momentum that has caused the number of participating companies to grow. Compared to when the moment in time when we started, the number of participating companies has more than doubled. And none of them is being paid, but all of them are being encouraged by possibilities to derive money one way or another. It differs from company to company, differs on your role in the value chain, as you will understand. But the most critical one may be the CSPs, the cloud service providers. They have a lot of investment and update necessity. They need to work on very low latency. They need to be the guardian angel for a lot of vehicles. They need to be on top of a lot of data, handle this properly. So the responsibility for them is, well, huge, and the cost accordingly, I would say. I am not the one to dive into their business model and explain it to you, but I sense there was one sitting here and he's gone. Before I ask you, after you ask, I'm not sure. But there is the possibility for them to sell information to governments. We try to discourage governments as much as we can to gather data themselves, to sit on top of a mountain of data, which they really don't know what to do with. And, well, it's probably also GDPR very, well, risky. So we encourage them not to collect data, but to have a subscription on answers. To ask the companies on the right-hand side, that red side, if you recall the slide, to ask for answers instead of gather data. Because they will be quicker, they are GDPR compliant by default, I'd almost say, whereas the other way around within the government area. So this is maybe a very interesting source of income. And on top of that, there is the professional users, the emergency services. They are really benefiting from being sure that the light on the crossings will be green instead of red. This reduces their time to get to the destination, and they will get paid by the average time it takes them in order to get to the destination. If this value is decreased in practice with a couple of seconds, it makes a lot of difference for them in the reward. So it's worth something for them to pay a service provider in order to help them achieving this. It's actually the case. Then there's the logistics sector, trucks, what have you. They are benefiting from the fact that whether instead of waiting for a light to turn green, can be sure that the light, because of their characteristics, their load, their time of the day, what have you, can be green, and they will be communicated that the line will be green. The light will be green once you arrive. So they need to brake less. They need to spend less fuel. They have less maintenance, less damage. All small, tiny parts, but together it makes a nice pie. So these professional users are definitely contributing. They have a paid-for subscription instead of the free information services most consumers use. These are paid-for services. So all in all, I think this makes up the pie for each of these service providers. I hope this comes up to your question. Okay. Any more of you that want to learn how to do this or not to do this? Then if not, oh, okay. Let me get to you. Thanks.
So for a lot of people, they don't have the equipment to comply with the talking traffic if your vehicle isn't new enough. For the traffic lights that will turn green in a couple of seconds, it does not matter. But for the restrictions, like in low emission zones, how do you cope with that?
Good one. To start with, a lot of people do not have the services. Yeah, that's true. But we've got about 8 million vehicles in the Netherlands. Currently, over 2.25 million, I think almost 2.5 million, do have the services. That's not all, but it's still a serious amount of equipped users. Moreover, as a consumer, there are several options for a free app that can help you. The free app can make it possible for you to not only communicate with the traffic light, but also to register for the reserved parking, to communicate to the enforcement cameras that you are compliant with the zero emission zone. That's a free app. You need to have a smartphone, that's for sure. But, well, that's not the biggest worry, I suppose. The average person has a smartphone. And you can ever more communicate between your smartphone and your car, which makes totally new solutions possible. If you have Android car, then the car can communicate specific characteristics to your phone and the other way around. So ever more steps are being taken to make this problem less, worrying. But again, yeah, you are right. As a truck driver, for instance, you need to have an integration with your fleet management system on board. That's the reason why we developed, together with a couple of fleet management system providers, plus a couple of crowd service providers, this interface, in order to make it as easy as possible for a largest group as possible to, well, solve this specific hurdle, to take this hurdle. Because we do want to make it as easy for people as possible when there is a commitment. There needs to be a commitment. If so, then there's a lot possible. But I'm not claiming we've got 100% penetration level, don't get me wrong. Does it answer your question? Okay. More of you. If not, then I'd like to thank you very much for your kind attention. Hope it was worth your time. If not, feel free to communicate this to us, because we want to learn from this as well. And if you'll, well, be in the office tomorrow or next week and think, I should have asked that question, don't hesitate to let us know. There is this website, Talking Traffic. There's the possibility to ask questions. They will end up with one of my colleagues, and sooner or later, I'm pretty sure that I'll get your question. So then you will be sure you get your answer. So there's several ways. Thank you for now, and wish you a good evening. Bye.